Welcome back, everybody. Today we're going to talk about section 2.4, working more with linear functions. A linear function has the basic equation y equals mx plus b, which is slope-intercept form. We could also say it's f of x is equal to mx plus b, because remember, y and f of x mean the same thing. The graph of a linear function is a straight line. M is the slope, which we can also call rise over run. B is the y-intercept. The domain of all linear functions is negative infinity to infinity, and the range is negative infinity to infinity. Remember, these are interval notations. If it doesn't ask for interval notation, then you can use the real number symbol. You would find the x-intercept by substituting 0 in for y, and you find the y-intercept by substituting 0 in for x. Giving the domain and range in the graph. So remember, this is going to be the y-intercept. I can make the number in front of x a fraction by putting it over 1 for the slope. So this is the slope, rise over run. So I'm going to make my coordinate grid. And start with plotting my y-intercept at 6. It's negative 2. So rather than rising, we're falling. Down 2, right 1. Down 2, right 1. Down 2, right 1. And connect our line. Remember, we want probably at least a good 4 ordered pairs on there, just to make sure we're a straight line. And because we are linear here, our domain is negative infinity to infinity. We can see that because we have an arrow on the left and an arrow on the right. And our range is negative infinity to infinity because, again, we have an arrow as our lowest and an arrow as our highest area. For number 2, the positive 2 is our y-intercept. The 3/2 is our slope, or our rise over our run. Make our grid here. And starting again with positive 2. At our y-intercept, we can either go up 3, 1, 2, 3, right 2. Or we can go down 3, 1, 2, 3, left 2. Connect those points. Make sure we have our arrows at the end. So here our domain is negative infinity to infinity, and our range is negative infinity to infinity. These two right here are note card problems. I would make sure that these get on my note card for my chapter test. I'm going to go ahead with number 3 and say, let's remember that f of x and y are the same thing. So this equation is y is equal to negative 3. This is a horizontal line, and it has 0 slope. 0 slope. To graph that, Y is -3. It's always -3. There's no x in this equation, so we don't even care what x is doing. So where's y -3? Well, y is -3 here, 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 all over. And so that's where we get our horizontal line. It also affects our domain and range. So for domain, on the left side, I still have an arrow going to the left. On the right side, I still have an arrow going to the right. So we have -infinity to infinity. Our range, however, we don't have any arrows going up or down. All we have is -3. That's all that y is. And so we have brace -3 for our range. For x is equal to 2, this is going to be a vertical line. And this has no slope. No slope. Vertical line, no slope. Graphing this, where is x2? Well, x is 2 here, 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 here. Don't care about what's happening with y because y is not even in that equation. So there's where we get that vertical line. And again, our domain and range are going to be affected by this. So our domain, well, we don't have any arrows going left and right. We don't have a set of points left and right. The only thing we have is that x is equal to 2. So our domain is a brace at 2. Our range, though, our range, we have an arrow at the bottom and an arrow at the top. Arrows mean infinity, so we're back to -infinity, infinity for our range. Standard form. AX plus BY equals C is standard form, where A, B, and C are numbers. We can rewrite standard form into slope-intercept form by solving for y. The steps for that are going to be to add or subtract the x and then divide everything by b. Finding the x and y intercepts are still the same by plugging in 0 for the opposite letter that you're trying to find. So if you're trying to find x, plug in 0 for y. If you're trying to find y, plug in 0 for x. Graphing the following equations, giving domain and range for each. So we can do this a couple different ways. We can do this by solving for intercepts, or we can do this by solving for slope-intercept form. If I solve this for slope-intercept form, we're subtracting the 4x because it's positive from both sides, and then divide everything by -5. So we have y is equal to 0. -4 over -5 is a positive 4/5 x. Our y-intercept is 0. Our slope, or rise over run, is 4/5. So if I make this graph, and I start with my y-intercept at 0, 0, And then rise over run. Rise 4, run 5, puts point right here. I could also go down 4 and left 5, because a negative and a negative is also a positive. And there's my line. Same thing over here for number 2. Subtracting 3x, and then divide everything by 4. So this gives us 1y is equal to 0 minus 3/4 x. This is our y-intercept. This is our slope, our rise over run. Plotting our graph. We started our y-intercept 0, 0, and negative 3/4. So we go down 3, right 4, or up 3, left 4. Connect those dots, and we have our graph. Slope. Slope is the steepness of a line, or the change in rate, change in y over change in x. We can use rise over run, or the formula y2 minus y1 over x2 minus x1. Now really, it doesn't matter which of these formulas we use. What matters is if we use the second parentheses first, that we do that both for x and y, or if we use the first parentheses first, we use it for both x and y. The zero slope is when the difference in our y coordinates are 0. This happens for all horizontal lines which have the equation of y equals some value, or f of x is equal to some value. No slope, or undefined slope, is when the difference in your x coordinates is 0. This happens for all vertical lines, or when you have the equation x equals some number. So finding slope. I like labeling my points so I don't forget. So if we do y2 minus y1 over x2 minus. Now be careful here because we're subtracting and we have a negative. So that negative still needs to be part. That negative doesn't replace the subtraction. So 2 minus negative 4. Well, negative 3 minus 8 more is negative 11. 2 minus negative 4, add the opposite, gives us plus 4, which is 6. So our slope is negative 11 over 6. For letter B, let's try this the opposite way. Rather than doing y2 minus y1, let's do y1 minus y2 and see if it comes out the same. So we would have 7 minus negative 4 over 2 minus 2. Well, add the opposite on the top. We get 11. 2 minus 2 is 0. Well, can't have 0 on the bottom. So this is no slope. And our equation there would be x is equal to 2 because that's what's being repeated there. For letter C, x2, y2, slope, we have negative 3 minus negative 3 over negative 2 minus 5. Add the opposite on the top. Negative 3 plus 3 is 0. Negative 2 minus 5 is negative 7. Well, 0 divided by negative 7 is 0. So this is 0 slope. And we'd have the equation of y is equal to negative 3 because of the negative 3's. You can solve any standard form equation into slope-intercept form. Y equals mx plus b, where m is the slope of the line. So we were practicing that a little bit earlier, but let's try it again. We subtract the x. So we have 3y is 12 minus 4x. And divide every single thing by 3. This makes 4 our y-intercept and negative 4/3 our slope. Subtract 2x and divide every single thing by negative 5. So we have y is equal to negative 2 plus 2/5 x. Negative 2 is our y-intercept. 2/5 is our slope. Point slope form. When you are given a slope and an ordered pair, or two ordered pairs, you can use point slope form to write the equation of a line. Point slope form can be changed into both standard form and slope intercept form. The equation is y minus y1 equals m times x minus x1. And in this equation, we only ever replace the y1, the m, and the x1. Notice I didn't include the minus signs in those boxes. So we write absolutely everything except the stuff in the boxes is what we change with the information we have. So if we're looking at example A here, they're giving us a point, negative 1, 5. That's our x1, y1. And our slope is negative 5/3. That's our m. So our equation, we would start with y minus y1 is 5 equals, I'm color coding this, you see what I'm changing, what I'm not changing. The slope is negative 5/3 times x minus x1 is negative 1. Now I would clean this up a little bit on the minus negative 1 part and say add the opposite. So that's y minus 5 is negative 5/3 times x plus 1. That would be point slope form for A. Point slope form for B, they're giving us two ordered pairs. I'm going to have to start with finding slope of those ordered pairs first. So negative 3 minus 1 over negative 2 minus 1 gives us negative 4 over negative 3, or positive 4/3. So it's not going to matter which ordered pair we pick to put into our point slope equation. You can pick either one. So if all they asked you for was point slope form, then we would accept y minus 1 is 4/3 times x minus 1 if we use the first ordered pair. If we use the second ordered pair, it would be y minus negative 3 is 4/3 times x minus negative 2. Now we would expect that you would go ahead and make that y plus 3 and x plus 2. All right, slope as a rate of change. So we have 2009. Google spent 2,800 million. I'm sure that's not the right words there. In research and development. Let's make that a little easier to see. There we go. And then in 2013, they spent 8,000 million on research and development. Find the average rate of change. Well, find the average rate of change means find the slope. So we have 8,000 minus 2,800 over 2013 minus 2009. That gives us 5,200 over 4, and that is 1,300. So they spent an average of 1,300 more each year on research and development. So let's try that for 2010. In 2010, they spent 9,547 million on research and development, and in 2013, they spent 8,658 million on research and development. Again, using the slope formula, I have 8658 minus 9547 over 2013 minus 2010. So that's negative 889 over 3, which gives us a slope of roughly negative 296.3 repeating, or 296 1/3. This means that they are decreasing their research and development spent for general science each year by roughly about $296 million. We are going to leave the last page for another time. This will get you going on your assignment. Thank you so much. You have a great day.